Okay, let's turn our attention to rational expressions and functions and multiplying specifically. We'll do a little bit of dividing here as well. We're building though on things that we've done in each of the last modules uh, in the past. Specifically today, we're going to be looking at finding domain of rational expressions. And then we're going to explore this concept of multiplying a rational expression by 1. And 1 can take many forms. It can be a 1, or it could be a 2 over 2, or it could be an x over x. We'll explore that a little bit and see how that can help us simplify expressions. So we'll simplify them, and then we'll use that same concept in multiplying and dividing rational expressions. So to begin with, a rational expression is one that has a fraction in it. Now, sometimes the number could be 5. That's a rational expression, we could say. Notice there's no denominator at all, but if I put over 1, immediately I have a numerator and a denominator. Typically, the ones that we're going to be looking at aren't like that. We're going to have some x's in there and other things. But really, an rational expression is one that has a top and a bottom. And we need to look at ways of simplifying those. To begin with, one of the things we have to always keep in mind whenever we have a rational expression in which there's an x in the denominator is that will be values for which this expression is not defined. And to find those values that they're not defined for, we do like we did in the last section, and we've done it a couple of times already. We say the bottom or this denominator cannot be equal to 0. So whatever number I plug in for x there that gives me a 0 on the bottom, I can't use that number because it gives me a 0. So the way I can do that is just take that denominator and say, well, 3x plus 4 cannot equal 0. And then solve the equation that results. Move the 4 to the other side. So 3x cannot be equal to negative 4. Divide both sides by 3. So x cannot be equal to negative 4/3. So this rational expression here is defined for every real number except for this number. Now we have a couple of fancy ways of saying that. Here's one of them. So all the values of x, as long as x is a real number and x is not negative 4/3. Another way I could write that is I could say, well, if I have a number line, here's 0 and here's negative 4/3 right about there, I could say I can use all the numbers from a negative infinity all the way up to here, okay, but I can't include that one. And then all the numbers on the other side of that all the way up to a positive infinity. And this is the way they write that. So from negative infinity to negative 4/3, not including, remember the square bracket means include, and from negative 4/3 up to positive infinity, and then it's the union of those two ranges of numbers or domains of numbers. Okay, sorry, there's a phone call, but I'm not answering. All right, let's keep going. Okay, so here's a question, and it says, for what values is this expression not defined? So what I can do is I can look at the bottom and say that's a quadratic. I'll factor that. Notice I'm not even going to worry about factoring the top. So it'll be x plus 3, x minus 3. Um, I think that's factored. Once it's factored, now I can say, well, x cannot be equal to a negative 6, and, oh, not equal to, and x cannot be equal to a positive 3. Notice I'm sort of skipping a step there. I just know that the number that I plug in there is a negative 6. So the domain for this function is all the numbers, the real numbers, except for negative 6 and a positive 3. Now, I said at the outset we're talking about factors of 1 and multiplying or dividing by factors of 1. Here's an example. where if you have rational expressions, if you multiply the rational expression by a factor of 1, it doesn't change the equality of that expression. It doesn't change the nature of the expression. It'll change, maybe give me, in this case, it'll give me a few more x's on top and x's on the bottom, but the expression remains the same. Because x over x is simply 1, multiplying by 1 doesn't change anything. So in this case here, multiplying by x over x doesn't change. I guess I could rewrite that as 2x squared minus 3x all over 3x squared plus 5x. So this expression is equal to this expression. I guess it's also equal to this whole thing when I multiply it by x over x. But if I multiply it by 1, it doesn't change the equality. If I want to plug some numbers in and just to test to see if that actually works out, try that. Try, say, plugging a 2 in. Well, let's do it. Let's plug a 2 in. So 2 squared is 4 times 2 is 8, minus 3 times 2 is 6, so I get a 2 on the top. 2 squared is 4, times 3 is 12, plus 10 is 22. I hope this will work. 2 over 22 is the same thing as 1 over 11. Let's see if we get that same thing just looking at this part. So 2 times 2 is 4, minus 3 is 1, over 3 times 2 is 6, 6 plus 5 is 11. Hey, it's the same number. So even though I multiplied by x over x, I'm not changing the equality of the expression. Typically, we're not going to multiply by x. What we're going to typically do is go backwards from that. Is we're going to take an expression like this and factor it, and then look for those factors of 1 that I can eliminate from the expression and help simplify. Okay, the rest of the questions on that page are doing the same thing. So here's what I'm wanting to do. I'm wanting to take each of these expressions and simplifying them. Now to simplify them, what I'm doing is I'm looking for factors of 1 that I can take out. I look here and I see, well, both of them have an x squared. This top one's got an x cubed, that's at least x squared, and this one has an x squared. So I could rewrite this like this. 8x times x squared over x squared. Notice that x squared over x squared is the same thing, and that's called a factor of 1. In the olden days, and still some people do this, they say, well, we can cancel those. And indeed, you can cancel them, but the concept is that x squared over x squared is simply 1. And multiplying by 1 doesn't change anything, just like I showed you on the last page. And so a simplification of this rational expression is simply 8x. Notice I was looking for factors of 1. Can do the same thing here. I can't really cancel this 5 with this 5 because there's a plus there and that sort of anchors it. However, I could factor that top. If I factor 5 out, I'm left with a plus 3 all over 5. You see where I'm going? And I'm going to get a 5 over 5 times a plus 3. Well, 5 over 5 is really a factor of 1, and 1 times anything doesn't change it. So the simplification of this rational expression is simply a plus 3. So it's a concept. Let's try a couple more difficult questions. Maybe this one here, and there's one on the next slide too. Oh, I was going to say careful with this one. Careful because a lot of people will just say, oh, well, 5 goes into 5, and then my answer is a plus 15. But you can't do that. Thou shalt not. The proper way to do that is to factor it first, and then take out any factors of 1. Let's try this one here. So I think 2x will go into each of them, leaving me with 3x plus 2 over, on the bottom, it looks like 4x will come out, leaving me with x plus 2. Okay, I'm dying to cross this x plus 2 with that x plus 2, but this has a 3 there. Those aren't identical, therefore I can't cancel them out. I'm stuck with them. But I do see that here that I have an x and an x. There's a factor of 1 right there. I could simplify that. So I could write that as 2 over 4, and then I have 3x plus 2 over x plus 2. And you're already saying, hey, you could do the same thing there. Let me do it the way I've been showing you, though. You could just cancel that and say it's a half. Or you can write it and say, well, that's 2 over 2 times 2. Notice that I'm just writing them as factors. I have a 3x plus 2 on the top there. And here, 2 over 2, that's a factor of 1. And so it cancels out. Therefore, the simplification would be 3x plus 2 all over 2 times x plus 2. Can't simplify it anymore. I'm dying to cancel those, but they're not identical. Therefore, no canceling. Try another one. Okay. Looks like I can factor something on the top. This bottom looks familiar too. Let's try it. Oh, 2 will divide evenly into everything on the top. Let's just get that out of the way right off the bat. And on the bottom, this looks to be a difference of squares. P plus 1, P minus 1. So I did a common factor on the top, difference of squares on the bottom. Let's continue with that top thing because this guy looks like a quadratic, p squared p and a number. So I can factor that into 2 factors. Let's leave this p plus 1 and p minus 1 on the bottom. Okay, so I have a p and I have a p. Product of 2 that adds to 3, well, that's just 2 and 1. So I'll have plus 1 plus 2. Now I look to see if I can get a factor of 1. Is there something identical on the top and the bottom? Sure enough, p plus 1 over p plus 1 would be equal to 1. So, like they used to say, I could cancel those out. Or, some people like rewriting it like this. 2 times p plus 2 over p minus 1 times p plus 1 over p plus 1. Okay, there's a times there. Since these are exactly the same, that's a factor of 1. So my final solution will simply be 2 times p plus 2 over p minus 1. This will be my simplified version of that, since this is simply 1. Okay, now, if you're multiplying rational expressions, you would do the same kind of thing, same game. With this one, I'm going to do the one on the next page, but with this one, I have a sum of cubes. I'd have to go to that formula and figure what that is. I think is it a minus b times a squared, and there's other stuff. I'd factor the bottom out times, I'd see if I could factor this top thing, see if I could factor the bottom thing, and then look for common factors on the top and the bottom that I can take out as being a factor of 1. Oh, there's the sum of cubes thing right there, plus. Anyway, you can try that on your own too. Let's do this division one. Okay, so here's dividing. When you divide fractions, as we've seen before, you invert and multiply. I'm going to do a couple of steps at once here, though. This top one, I know I can factor that. That's x plus 5, x plus 2. Again, hopefully you are getting so you can do those fairly quickly. Bottom, there's a common factor of 2 that can come out. When I'm dividing, I'm going to invert and multiply. So the x minus 2 comes up top, and then this goes to the bottom. And let's factor it as we go. So it'll be x minus 5, x plus 2. Is that right? Minus 5 times 2? Yep. And this would be plus 2x minus 5x is minus 3. Yeah, that's correct. Okay, so now I look for common factors of 1. We can rewrite it as I've been doing on the other page, but typically what we look for is At this point here, we just start canceling, or we start looking for that factor of 1. Here's an x minus 2, x minus 2. There's a factor of 1 that I can get rid of. An x plus 2 and an x plus 2, I can get rid of that factor of 1 too. I'm dying to cancel these ones or get rid of this factor of 1, but they're not identical, so I'm stuck with them. So my final answer would be x plus 5 over 2 times x minus 5. Okay, so hopefully that'll give you a little bit of practice dealing with rational expressions in both looking at finding values for which they're not defined and also simplifying them by looking for factors of 1.